We'll start with the laws of motion. Heading: Newton's laws of motion. Newton had written the three laws in his famous book called Principle. In his own words, please write the first law. Every body perseveres. Every body perseveres as it maintains or continues. Every body perseveres in its state of rest. Perseveres in its state of rest or of uniform motion. Perseveres in its state of rest or of uniform motion in a right line. Right line means a straight line. Every body perseveres in its state of rest or of uniform motion in a right line unless it is compelled to change its state. Unless compelled to change its state. Unless compelled to change its state by forces impressed upon it. Unless compelled to change its state by forces impressed upon it. Unless compelled to change its state by forces impressed upon it. So what we mean by it, let's understand it in simple terms. First law has to do with inertia of the body. First law has to do with the inertia of a body. Now inertia of a body are of two types. What are they? Inertia of rest and inertia of motion. The first law talks about inertia. If the body is at rest, it would want to remain at rest. If the body is in motion, it would want to remain in motion in a straight line with a constant velocity, unless what? Unless there is a external force acting on it. Okay. So until and unless the resultant external force is non-zero, the inertia of the body would not break. Only if the resultant external force is non-zero, the body by inertia will break. So let's take the two cases. If I assume that there is a block of mass, say 10 kg placed on the ground, 10 kg block initially at rest. Now if I apply external force, what will happen? Will it start moving? Just application of external force is not the criteria. What is the criteria? It should be a resultant non-zero external force. Suppose if I apply two external forces, F1 and F2. Due to the application of these two external forces, will the body start moving? Will the body start accelerating? It depends on the values. Okay, so if I assume that the force F1 is 10 newtons I cap and the force F2 is 10 newtons minus I cap, what can I say? There are external forces, not one, there are two external forces, but the resultant external force is what? The resultant external force is 0. And since the resultant external force is 0, the body will continue to maintain its inertia of rest. Okay? So the first law says that if the resultant external force on the body is 0, a null vector, force is a vector quantity. So if the resultant external force is a null vector, absence of external force is not the criteria. There might be external forces present. What is the criteria? The resultant external force should be 0. So if the resultant external force is 0, what can I conclude? What else will be 0? The acceleration of which point? Acceleration of which point of the body will be 0 if the resultant force is 0? Center of mass. I am not sure about other points. Other points might have an acceleration even when the force is 0, but the center of mass definitely will have no acceleration. For example, if I assume a rod and I apply two equal opposite forces on the rod, say 10 newtons each, what can I say? Will the body be at rest? Will the body get rest? No. It will start accelerating, it will start rotating. So different points will have acceleration. Why? Because associated, centrifugal acceleration is associated, but which point is still not having any acceleration? The center of mass of the body is still not having any acceleration. So if the net force on a body is 0, I am not very sure about the other points, but I am definitely sure about the center of mass, that its acceleration will be 0. So if the net external force of the body is 0, the acceleration of the center of mass of the body will be a null vector. If the acceleration of the center of mass is 0, what can I conclude about velocity of the center of mass? It would remain constant. Why? Because acceleration is rate of change of velocity. Acceleration is rate of change of velocity. If the acceleration is 0, the change in velocity will be 0. And if the change of velocity is 0, the velocity will remain constant. I can conclude that VCM will remain constant. VCM will remain constant. And this constant value might be 0, it might be what? It might be equal to 0, it might be non-zero as well. If it is 0, what would it be? What would it represent? If the constant value is equal to 0, it means it would represent inertia of rest. And if the constant value is non-zero, it would represent inertia of motion. Okay? If the constant value is 0, it would represent inertia of rest. And if it is non-zero, it would represent inertia of motion. So there are two types of inertia, either of rest or of motion. If a body is moving, it would like to continue the motion in a straight line with a constant velocity. Let's assume that the velocity is 5 meters per second like that. And so what will this body like to do if the resultant external force on it is 0? It would like to move in a straight line with a constant velocity. The path will be a straight line and the motion will be a uniform translation. The motion will be a uniform translation. Uniform translation मतलब क्या? Velocity will remain constant. It will remain 5 meters per second. Okay. Even if I apply two forces, two external forces on it, so long as the net force is 0, it will continue to move with a constant velocity. Okay. So the first law talks about the inertia of the body. What do you mean by inertia? It is the tendency of the body to remain in its own state. If it is at rest, it would love to remain in rest. If it is in motion, it would love to remain in motion in a straight line with a constant velocity. Unless what? Unless the resultant non-zero external force acts on it. Okay? The resultant external force should be non-zero. Only then the inertia of the body will be broken. Okay? If the resultant external force is non-zero, only then the inertia of the body will be broken. Okay? Resultant external force should be non-zero for inertia to break. For inertia to break, the resultant external force should be non-zero. Fine. Simple idea. So long as the force is 0, the acceleration will be 0, center of mass of velocity will be constant. If the constant value is 0, we call it as inertia of rest. And if the constant value is non-zero, we call it as inertia of motion. And so mathematically, how do I apply first order problems? Mathematically speaking, the first law we applied in this manner. We never write down the equation in this manner. We always write it along x and along y separately. We always analyze the motion along x and y independent of each other. So we do the same here as well. We would say that if the sum of all external forces along x add up to 0, sum of all external forces along x, so if there are 3 forces, I would find out the x component of all the 3 forces and add them up. If the sum adds up to 0 or null vector, what can I conclude? The acceleration of the center of mass along x will be 0. I can also conclude the other way down. It is a vice versa thing. If the acceleration is 0 along x, the net force along x also must be 0. Okay. Similarly, I can do the same along y. What is it? If the net force along y will be 0, the acceleration of the center of mass along y will be 0, and vice versa. Acceleration of the center of mass along y will be 0 and vice versa. Okay. So this is the mathematical version of the first law that you apply so far as problem solving is concerned. Okay. Mathematical version of the first law. Simple. Net force along x will be 0. The center of mass, the acceleration along x component of the acceleration will be 0. And so the inertia is maintained along x. If the net force along y is 0, net acceleration along y will be 0. Inertia will be maintained along y. So So if I take a very simple example, let us assume my xy axis and the particle is at the origin, and I apply two forces on the particle, F1 and F2, in different directions. I apply two external forces, F1 and F2. F1 is a 10 Newton force towards the first quadrant and F2 is a 10 Newton force towards the second quadrant. The angles are 37 degrees each. Then you can tell me along which direction would inertia be maintained, along which direction would the inertia be broken, etc. Along x it will be maintained. So to find out whether the body is accelerating along x, what will I do? I will resolve the forces along what direction? Along the x direction. So F1 can be resolved as what? F1x and F1y. F1x will be how much? 10 cos 37. Cos 37 is 4 by 5. And so I get this as 8 newtons I cap. Similarly, F1y will be how much? 6 newtons. J cap y plus 10 sin 37. Sin 37 is 3 by 5. Similarly, what else will I do? I'll resolve F2 along the x and y components. What is the x component? 10 cos 37 will be 8 newtons minus I cap, and what? F5 will be, F2y will be 6 newtons plus J cap. 6 newtons plus J cap. What can I now conclude from these resolutions? Sum of all forces along x, there are two forces. What are their x components? Adding up to. Sum of all forces along x are adding up to 0, and so I can say that the acceleration of the center of mass along x is 0. Right? Initially, the particle was at rest. It will continue to remain at rest along x. It will continue to remain at rest along x. Acceleration is 0, velocity is constant. The value was 0 initially. The velocity along x will remain 0 forever. In this case, the velocity along x will continue to remain 0. And so, along x, what inertia is maintained? Which type of inertia is maintained? Inertia of rest is maintained along x. What about y? What is the net force along y? 12 Newton J cap. So what they say, will the body remain at rest along y? No, it will start moving. So along y, the body is no more at rest. It has started moving. Is the inertia of motion maintained? Inertia of rest is not maintained along y. That is very clear. Is the inertia of motion maintained along y? Inertia of rest is not maintained along y. It is very clear. There is a force, the body will start moving. So there is no inertia of rest maintained along y. Is the inertia of motion maintained along y? No. Why? Inertia of motion says that it should move with a constant velocity. It is not moving with a constant velocity. Direction there will be a acceleration. Okay, since the force is non-zero, the acceleration along y will be non-zero, and so the velocity along y will not remain constant. So along y, neither is inertia of rest maintained nor is inertia of motion maintained. Please write this point down. As the net force along x is 0, as the net force along x is 0, inertia of rest is maintained along x. Inertia of rest is maintained along x. Along y, the body starts moving. Along y, the body starts moving. And so what is not maintained? And so inertia of rest is not maintained along y. Along y, as the body starts moving, inertia of rest is not maintained along y. What else is not maintained along y? Inertia of motion is also not maintained along y. Why so? Because along y it is moving with a what motion? An accelerated motion. Inertia of motion says what? It should move with a constant velocity. Okay, write that down. As the body accelerates along y, as the body accelerates along y.
So how is acceleration not equal to
Force non-zero is acceleration non-zero. Acceleration is force by mass. You can write it down. As the body accelerates along y, the inertia of motion is also broken along the y direction. As the body accelerates along y, inertia of motion is also broken along the y direction. Clear? How should the body move to maintain inertia of motion? It should move with a constant velocity. It is moving with an acceleration. So along y there is no inertia of rest, nor inertia of motion. Along x what is maintained inertia of rest. Clear with it? Simple example.
So what is straight line uniform?
Sorry. Uniform translation. Uniform translation of the constant velocity. V equal to constant. So that is first law. This is the mathematical form of the first law that you need to apply. You can apply it either ways. If the net force log x is 0, ACM x is 0. Vice versa, if ACM x is 0, net force log x is 0. Let's now go to the second law. So first law talks about inertia. Inertia is the tendency of the body to remain the way it is. If it is at rest, it would want to remain at rest. If it is in motion, it would want to continue moving in a straight line with constant velocity. Let's now go to the second law. What does the second law talk about? It talks about the rate of change of momentum. Okay, what is momentum first of all? Mass into velocity is the product of m and v. Is it a vector quantity or a scalar quantity? Momentum? Vector, okay. Is it a dot product or a cross product? M into v. M into v, what is it? Then what is it? If it is either of the two, what is this? It is a multiplication of a scalar and a vector, okay? Dot product and cross product, both of them, in both the cases, you need two vectors to be multiplied, okay? Generally, students forget the third one. When you multiply a scalar and a vector, when you multiply a scalar and a vector, the result is always a vector. When you multiply two vectors, it is arguable, okay? When you multiply two vectors, you can end up with a scalar result, you can also end up with a vector result. But when I multiply a scalar and a vector, the result must always be a vector quantity. The result must always be a vector quantity, okay? So it is the third type. Mass into velocity, mass is a scalar, velocity is a vector. The product has to be a vector, momentum. Okay? And the unit is kg meters per second. M into V is kg meters per second. So the second law talks about the change of momentum, the rate of change of momentum. What does it say? The rate of change of linear momentum, write that down please. That is the statement for second law. It states that the rate of change of linear momentum. It states that the rate of change of linear momentum of a body is directly proportional to what? Is directly proportional to the resultant external force applied to the body. Is directly proportional to the resultant external force applied to the body. Is directly proportional to the resultant external force applied to the body, and it takes place. What takes place? The change of momentum, and it takes place in the direction of, and it takes place in the direction of the applied force, and it takes place in the direction of the applied force. I repeat, the rate of change of linear momentum, orbit type of momentum होता है, any other type of momentum that you know. We are talking about linear momentum now. Any other type of momentum that you know? Atomic structure, chemistry. Angular momentum, electrons revolving around. What is the formula for angular momentum? MVR. Okay. So we are talking about linear momentum now. What does the second law say? The rate of change of linear momentum of a body is directly proportional to what? The resultant external force applied to the body, and it takes place. What takes place? The change in momentum takes place in this direction, in the direction of the applied force. The change in momentum takes place in the direction of the applied force. So mathematically, the second law is this: delta P by delta T is proportional to what? The resultant external force. This is what is the second law mathematically. Can you prove it? Can you prove second law? It is a very simple proof. Let's do that. So to prove Newton's second law. Okay, so the rate of change of momentum is directly proportional to the resultant external force. We'll have to prove it. Let us assume that there is a block of mass m having an initial velocity vi, at time 0 and you apply an external force starting at time t equal to 0, you apply an external force starting at time t equal to 0 up till time t, what will happen as a result of this external force? The body would accelerate, and due to the acceleration, it would increase the velocity, the speed will increase. Why? Because the acceleration will be in the same direction as velocity. If the acceleration and velocity are in the same direction, the body speeds up. For this case, try to prove me the second law. For this case, try to prove the second law. Try to find out the LHS of the second law, rate of change of momentum. Simple derivation and try to out this. Find the rate of change of momentum. So delta P by delta T, change is what? Change is final minus initial, so P final minus P initial by P final minus P initial. Okay, change is always final minus the initial value. What is the final momentum? Final momentum is M into P final minus the initial momentum M into P initial by what? T minus 0. I can take M common, it is P final minus P initial by T. Okay, and so what is P final minus P initial by T? It is the acceleration of the center of mass ACM. And so we get delta P by delta T is equal to M into vector ACM, and that is equal to the resultant external force. Okay, so this is the proof for Newton's integral. What you're saying that is arguably the most important equation in all of physics. Definitely the most important equation in all of mechanics. Okay, Newton's second law. There are three terms in it. All three terms are vector terms. All three terms are vector terms, and in the vector terms have to be equal to each other. They must be equal in magnitude as well as equal in direction. Okay, so they must have same magnitude as well as same direction. Only then you can equate two vector terms. There are three vector terms in this equation. All the three must have the same magnitude. All of them must have the same direction. Okay. How do we apply it in our problems? Let's understand that. The version of the equation that we apply in our problems, we write it as net force along x is equal to m into acceleration of the body along x. Similarly, the net force along y is equal to m into the acceleration of the body along y, m into ac by u. This is the formal second law that you apply while solving problems. Okay, Newton's second law for while you apply while you solve problems. Summation fx is equal to max summation Fy is equal to Fy. So from second law I can conclude first law. How so, tell me? From second law, how can you conclude the first law? You can see that if the acceleration along x is 0, what will happen? The net force along x will add to 0. Similarly, if the acceleration along y is 0, the net force along y will add to 0. So you can conclude first law from the second law. That is why second law is more important than the first law. Clear? The third law, what does the third law say? Statement wise, it is the easiest. What is it? So every action, there is an equal and opposite reaction. So it is the easiest to state, toughest to understand. Let us have the third law. Will you read this law? So the second law equation that we did, delta P by delta T is proportional to the resultant external force. What can I say about the proportionality constant? The proportionality constant is what? Is 1. Any equation of the form y proportional to x, you write it as y equal to kx, k is the proportionality constant. यहाँ पर the second law says that the rate of change of momentum is proportional to the resultant external force, and that proportionality constant comes out to be 1. Okay. The proportionality constant k is equal to 1 over k. Fine. Let's go to the third law. What is the statement for the third law? If one body applies a force on the other, if one body applies a force on the other, if one body applies a force on the other, then the other applies the same force. Then the other applies the same force in opposite direction on the first one. Then the other applies the same force in opposite direction on the first one. I repeat, if one body applies a force on the other, then the other applies the same force in the opposite direction. Then the other applies the same force in the opposite direction on the first one. Then the other applies the same force in the opposite direction on the first one. Okay. So now, mathematically speaking, the third law can be simply written as reaction force is equal to minus of the action force. That is the mathematical version of the third law. Reaction force is equal to minus of the action force. What is the negative sign indicate? They must be in opposite direction. Third law talks about two forces, action force and a reaction force. And there are 3 points to remember about these forces. Can you tell me what are the 3 points to remember? What can I say about the properties of the 3 forces? They must be what? Equal in magnitude wise, they must be equal. The 2 forces must be equal in magnitude. What else? They must be opposite in direction. What else? The third and the most important point. The forces must act on 2 different bodies. This is a very, very important point. The forces must act on 2 different bodies. They act on 2 different bodies. Action and reaction forces never act on the same body. Very, very important. Action and reaction forces never act on the same body. They always act on 2 bodies. Okay, on 2 different bodies. So third law is always associated with a 2-body or a multi-body system. It can never be applied for a single body. First law, second law, you can apply it to a single body system. But whenever you apply third law, you can only apply it for a 2-body system. It can never be applied to a single body. Okay? So third law always is for a 2-body system or a multi-body system for that matter. Why? Because it talks about 2 forces and the 2 forces must act on 2 different bodies. They can never act on the same single body. Let's take a few examples to understand. Let us assume that there is a block placed on the ground. Okay. Tell me what are the forces acting on the block. What are the forces acting on the block? There will be a gravitational pull of the earth. All the particles inside the block will get a small little gravitational pull of the earth, and the resultant of all these small little forces will be the resultant of the weight of the body. The resultant of all these small little gravitational pulls is what you call as the weight of the body. So weight of the body is acting there on the block. Any force which I should mark on the ground? Any other force on the block? Tell me.
Reaction.
The force from the ground, the force from the ground on the block. Okay, and so I am marking it as FGB. Force from the ground on the block. We write it as F source to the object. The source is the ground and object is the block FGB. What can I say about these two? They are the action-reaction pair? Yes. Obviously not. They are not the action-reaction pair. Why? They are acting on the same body. They are equal in magnitude, very true. Opposite in direction, true. But they are acting on the same body. They cannot represent action-reaction pair. Many students confuse this to be action-reaction pair. FGB is the force from the ground on the block. Okay, the block is kept on the ground. The block must be pressing the ground, and so the ground will be giving back some reaction force, and that reaction force is what I have marked as energy. But they are not the action-reaction pair. Please realize it. Any force which I should mark on the ground, anything which you suggest? What should I mark on the ground? The weight of the block is pressing the ground. So should I mark the weight on the ground as well? Yes. Weight should I mark on the ground? This is again a very important point. Please remember, weight of a body must always be marked on the body and not on the surface the body is placed. Never must you mark the weight acting on the surface. There will be some pressure sort of a thing acting on the ground, but that is not marked as the weight. That is going down as a note. Very important. Weight of a body must always be marked on the body. Weight of a body must always be marked on the body and not on the surface. And not on the surface the body is placed. Weight of a body must always be marked